Now that we understand how to plot individual points in the rectangular coordinate system, we're going to relate it to equations. This is note C.1 part 2, solutions of equations in two variables. This comes from section 3.1 of the textbook. In order to do this section, you want to recall how to determine if a number is a solution to an equation. You want to know how to apply order of operations to simplify an expression. And you want to understand how to solve a basic equation for an indicated variable. Upon completing this presentation, you will be able to determine if a point is a solution to an equation in two variables, find solutions to an equation in two variables, understand the difference between an equation and an ordered pair, and have a basic understanding of the relationship between an equation and the solutions to the equation. So let's start with some vocabulary. A solution of an equation in two variables is a point or ordered pair, x, y, that yields a true statement when plugged into a given equation. What we are doing here is extending what we did in the previous module. But instead of just plugging in one number, we're going to be plugging in two. Note that in the previous module, we found that we had three possibilities. You could have one solution, infinite many solutions, or no solution. When we talk about equations in two variables, there is always going to be an infinite number of solutions for an individual equation in two variables. So let's go ahead and review what we did in the previous module. Let's look at the two examples here. And I want to know, is the number a solution to the equation? So recall that what we want to do is plug it in and check to see if it's equal. So for the first one, I want to go ahead and replace x with 5. So we get 3 times 5 plus 4, and I want to know, is this equal to 13? Well, if we multiply 3 times 5, we get 15 plus 4. On the right side, we still have 13, and 15 plus 4 is equal to 19. The right side is equal to 13. So 5 is not a solution. If we look at the second example, we have 3 plus 4 equals 13 again, and I want to know, is 3 a solution? So if we plug in 3, we get 3 times 3 plus 4, and I want to know, is this equal to 13? Well, 3 times 3 gives me 9 plus 4. My right side stays the same, and we get 13 equals 13. And this does check out, so 3 is a solution. Okay, so now what we want to do is extend the concept into equations in two variables. So if we look at the above example, we have x minus 4y equals 14. So remember that our ordered pairs, we always have that our first coordinate is x, and our second coordinate is y. So we want to replace any x's that we have in our equation with 2, and any y's in our equation with negative 3. So if we do this, we get 2 minus 4 times negative 3. And I want to know, is this equal to 14. So again, in order to simplify this, I want to start by multiplying -4 and -3. We get 2 plus 12 equals 14. And if I simplify the left side, we get 14 equals 14. So 2 -3 is a solution. So let's go on to the next one and see if 3 -2 is a solution. I'm going to do the same thing again. I'm going to replace x with 3. I'm going to replace y with -2. So if we plug these in, we get 3 minus 4 times -2, and I want to know, is this equal to 14? Same thing again. I want to multiply -4 and -2, we get plus 8, and I want to know, is this equal to 14? Well, 3 plus 8 is 11, and is 11 equal to 14? No. And so what we end up with is 3 -2 is not a solution. Let's try -2, -4 now. So we're going to replace -2, or x, with -2, and we are going to replace y with -4. So if we go ahead and plug this in now, we get -2 minus 4 times -4, and I want to know, is this equal to 14? Same thing, I want to start by multiplying -4 and -4. We get positive 16. My right side is still 14. And now -2 plus 16 does equal 14. And we do get a true statement. And so -2, -4 is a solution. All right, last one. We have 5, 2. So I'm going to replace x with 5, and I'm going to replace y with 2. So if we go ahead and plug this in, we get 5 minus 4 times 2, and I want to know, is this equal to 14? If we multiply, we get 5 minus 4 times 2 is 8. And I want to know, is this equal to 14? Well, 5 minus 8 is -3, and that is not equal to 14. So we get 5, 2 is not a solution. But the main thing that I want to point out here is that, notice that we did have 2 points here that were solutions. We also had 2 that were not. And so when we talk about equations in 2 variables, again, there's going to be an infinite number of solutions. There's also going to be an infinite number of points that are not solutions. We can always find more. So let's try another example and see what we can do with this. Same idea, I want to go ahead and plug in 2 for x and -3 for y. If we do this, we end up with 3 times 2 minus -3, and I want to know, is this equal to 9? Well, we get 3 times 2 is 6, minus -3 is going to become +3, and 6 plus 3 is equal to 9. So 2, -3, this is a solution. Okay, well, what about 3, -2? So if we plug in 3, -2, again, I want to replace x with 3 and y with -2. We can go ahead and plug this in. We get 3 times 3 minus -2. Is this equal to 9? 3 times 3 is 9, minus -2 becomes +2. 9 plus 2 is 11, and 11 is not equal to 9. So 3, -2 is not a solution. Okay, let's try -2, 4. If we plug in -2, 4, we're going to get x will be replaced with -2, and y will be replaced with 4. We get 3 times -2 minus 4 equals 9. 3 times -2 gives us -6. If we combine that with -4, we get -6 and -4. They have same signs, so we are going to add and keep the sign. We get -10 is not equal to +9. So -2, 4 is not a solution. So finally, for example D, we want to replace x with 5, y with 6. And so if we go ahead and plug this in, we get 3 times 5 minus 6, and I want to know, is this equal to 9? 3 times 5 is 15 minus 6, and 15 minus 6 is equal to 9, so we do get 9 equals 9. And so 5, 6 is a solution. Okay, so hopefully this helps you determine if points are solutions. And so one of the things that we will be using this later when we start working with just equations. So let's go ahead and move on to how do we find solutions. So finding solutions to an equation in two variables. You may think at first, okay, well, how am I supposed to pick two numbers that will work? And so what we do is we don't pick two numbers. We are going to start with just one. Now remember that there is an infinite number of solutions. So the first thing we want to do is just select any number and plug it in for one of the variables. We substitute it into the equation, and we're going to solve for the other variable. We use the two values, the one you chose and the one you found, to create an ordered pair xy. The ordered pair is a solution. So recall that since there are an infinite number of solutions or points that satisfy an equation in two variables, you can do this more than once. Each time you choose a new value to plug in, you are obtaining a new solution or point that satisfies the equation. So let's go ahead and look at these examples. Example 1, we have the equation y equals 2x minus 1. The first thing I want to do is we're going to use values of x from -2 to 2 in order to find 5 solutions. Now note, -2 to 2, there is nothing special about this. It's just nice that we have some small numbers that we're going to plug in. So if we look at example 1, I'm going to go ahead and start by plugging in x equals -2. And to make this a little easier, I'm going to create a table. On the left side, I'm going to have my x. On the right side, I'm going to have my y. And so for my x's, I want to plug in the values -2, -1, 0, 1, and 2. And we want to figure out what y is equal to. Now, I will state that the purpose of this is not being able to do the computations, because we're going to be doing these multiple times. So feel free to use your calculator on this. As I don't have a calculator, I will go ahead and go through the computations by hand. As you have a calculator, make sure that you're getting the same answers that I get. So in order to do this, we're going to plug in -2 for x, and I want to simplify for y. If we plug in -2, we get 2 times -2 minus 1. 2 times -2 is -4 minus 1. And if we combine this, we get -5. So I'm going to record the -5 in my table. Okay, we're going to start again. And I want to do the same thing with -1. So I get y equals 2 times -1 minus 1. I can multiply 2 times -1 to give me -2 minus 1. And if we combine this, we get -3. Again, same signs. We add and keep the sign. So this is my y value, and I'm going to record that in my table. Let's repeat the process with 0. So if we plug in 0 to our equation, we get 2 times 0 minus 1. 2 times 0 is 0. Minus 1 is -1. So we will record that in our table. Same thing with 1. We get y equals 2 times 1 minus 1. 2 times 1 is equal to 2. Minus 1 gives you 1. And for the final one, we want to plug in 2 for x. So I get y equals 2 times 2 minus 1. We multiply 2 times 2, we get 4, minus 1 equals 3. So now, if we write this in ordered pair form, remember that our ordered pairs are always going to be x, comma, y. So the first one, we get -2, comma, -5. What this says is when x equals -2, y equals -5. For the second one, we get the point -1, -3. Same thing. What this says is in our equation, when x equals -1, y equals -3. We also have the point 0, -1. 1, 1, and 2, 3. So these are 5 solutions that satisfy the equation, but note that they are not the only solutions. We still have an infinite number. All right, let's look at example 2 now. Example 2, I want to plug in the same values for x. And we want to figure out what y is equal to. So I want to plug in -2, -1, 0, 1, and 2 for x and solve for y. Now this is going to involve actually solving, not just simplifying one side of the equation. So let's go ahead and see what happens when we plug these in. If we plug in -2, we get 3 times -2 minus y equals 4. I can multiply this together, giving me -6 minus y equals 4. From here, in order to solve for y, I need to get rid of the -6. So to get rid of -6, I want to add 6 to both sides. We get -y equals 10. And finally, I want to get rid of the minus sign. So we want to divide by -1. And we get y equals -10. Okay, so now let's repeat the process for x equals -1. So I'm going to replace x with -1. Multiply gives us -3. We want to add 3 to both sides, giving us -y equals 7. And then I want to divide by -1, giving me y equals -7. And so I will report that in my chart as well. When x equals -1, y equals -7. Similarly for -2 and -10. Okay, that takes care of our second point. So let's look at our third point. We want to plug in 0. We get 3 times 0 minus y equals 4. 3 times 0 is 0 minus y equals 4. If you want, you can go ahead and just cancel that out. So we are left with just minus y equals 4. And I want to divide by -1. So we get y equals -4. So I will report that in my table. Again, when x equals 0, y equals -4. All right, 2 more to go. The next one, we want to plug in 1. So I'm going to replace x with 1. And again, solve for y. So we get 3 times 1 is 3. Bring everything else down. I want to subtract 3 from both sides. We get -y equals 4 minus 3 is 1. And then, to get rid of the negative, we divide by -1, and we get y equals -1. So I will report that in my table. Again, what we have here is when x is 1, y is -1. And then for our final number, we want to plug in 2. So we get 3 times 2 minus y equals 4. 3 times 2 is 6, minus y equals 4. In order to get rid of positive 6, I want to subtract 6 from both sides, leaving me with negative y equals negative 2. We have different signs here, so we're going to subtract and keep the sign of the larger number. And then I want to divide both sides by negative 1, giving me y equals positive 2. So I will record that in my table. When x is 2, y is 2. And then now for our ordered pairs. The ordered pairs that satisfy this equation, or some of them that satisfy this equation, we have negative 2, negative 10, negative 1, negative 7, 0, negative 4, 1, negative 1, and 2, 2. So as you can see, this can be very tedious, but that is basically how you find solutions to an equation involving two variables. So when will we see this again? Finding and plotting points is the first step to graphing linear equations, or any equation in two variables. We will revisit these concepts when we talk about graphing quadratic equations later in the semester. And as you progress through your math classes, you will continue to talk about graphing various types of equations by finding and plotting points. For this section, the main thing is finding points. And the basic concept of this is always plug in and solve for the other variable. As part of your notes, please answer the following questions and bring them to class. How confident are you with the material presented in this section? What from this section needs to be explained further? And how much more practice do you need to be comfortable with the topic?